Okay, let's go on talking about relational databases. Previously, we have seen that a junction table can connect more than two tables. Now we see an example in which it connects even 4 tables and in which the junction table is not just a technical trick to build a many-to-many relation, but it's the core table of the entire database. So this means that the junction table is a table as any other else. It's not just a trick, so it's a table and can really contain also meaningful information. It happens often that it contains information that it's even more important than the information contained in the other tables. And let's see, in fact, in this example. The example talks about car parts. When you go buying a car, usually you have the opportunity to customize your car a lot. So you have the opportunity to choose the internal parts, the external parts, to choose the engine, the tires, and a lot of other options in your car. Usually these options are rather standardized, so you cannot choose any seat of a different color. No, if you choose the internal of a certain color, everything will be accordingly modified. So these options are rather standardized, but they can be customized and put together to form your car. So let's see how to handle this database. Okay, as usual, I go here. Okay, one. Okay, first part is the engine. Let's build a table containing informations on engines. Let's make it smaller so we fit engines, better engine types. Okay, engine ID. Okay, what are the features of an engine? Well, the size. The size usually is in cubic centimeters. The power, the fuel type. Okay, it can be standard gasoline or other types of fuel. Other, maybe the manufacturer. Okay, and the model number, model name. Okay, this is the primary key. Well, the model name could be the primary key, but sometimes the same model names apply to different engine types. So this is the engine that you can customize. Let's go to the external part of the car. So let's build another table here. Will I fit it? Okay, like this. I try to use as much space as I can in this direction. Okay, this is the external. Okay, well, let's use the ID because it will be our primary key. What can you customize of the external part? Clearly the color. Okay, well, the shape, because you know, cars can have the last part just going on to have more space inside or things like that. The number of doors, okay, famous car with 3 or with 5 doors, etc., etc. Something else, whether it's a sport setting, it is a yes no field, okay, and clearly tons of other features, but since we are not selling cars, we don't care too much about the rest. Let's see the internal parts. Oops. Okay, we should fit internals ID. By the way, this is a primary key, and this also. Sorry for the interruption. Okay, let's go on to internals. Well, what can you see? Whether they're made of leather or not. The type of steering wheel. Steering wheel. Steering wheel is the things that you use to move your wheels. Okay. The steering wheel can be a sport one, a standard one, made of wood or whatever. What else? Well, the color also here, and several other. The radio, whether it has a radio, whether it has a navigation system. Okay, and now let's go on to the last table. Clearly, if you want to build a real database, I think there are at least 10 different tables because 10 different customization sets. Let's talk about tires. Okay, ID. Okay, tires have a size, which by the way is measured in an extremely complex way, a manufacturer, so a brand. They can have also color. I've seen also white tires around, and they can be winter or winter. Or I put winter, and it's a yes no. It's no if there are summer tires. Okay, and let's stop like this. When you buy a car, what should this database do? This database should choose one engine type, one external setting, one internal setting, and one set of tires. The tires are always 5, so, and join them together into a super junction table here, which we will call cars. Okay, ID, engine, external, internal, tires. That's it. Primary key, it's this one. Okay, relations, engine with engine, external with external. The relation with a junction table, it's always like this. Foreign keys in the junction table and primary keys in the other tables. Oops, I wrote types instead of tires. Ouch. How can I now remove it? I need to take this one, make it larger, switch to white. Okay, switch back to black. Take this one. Okay. Now, here clearly 1, 1, 1, 1, and many. Let's see if I'm able to do it. Many, 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 and many. Okay, just checking to be sure. For each engine there are clearly many cars, so I hope that the engine we build goes into the engine type goes into several different cars, otherwise it will be a failure. Each car contains only one engine. Okay, each internal settings goes into different cars, the internal setting type, and each car contains only one internal setting type. A type of tires goes into many cars, and the cars contain only one set of type of tires. One car contains only one external type, and each external type goes into different cars. So, well, but for junction table, it's usually pretty standard. Okay, which other fields can we put into the junction table? Well, let's talk about the owner, because this junction table represents your car. Can you see why before the junction table could represent just a simple trick, even though I would say in the exams database it was the most important aspect of the entire database. Here it represents the car, so it's the most important aspect of the database. So the owner, let's say the name and surname of who has booked at least this car. If you want, you can have a customers table here on the side, and this can be a foreign key for the customers table. Or if you want to build your database, keep your database much simpler, you can just write here name and surname of the person who booked the car. And let's talk about the cost. Well, a reasonable and logical approach would say that the cost be written here, 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 and here. And then the cost of the car will be a sum of the cost of the engine type, internal type, tire types, multiplied by 5 or 4, and external type. This would suggest the logic. So the cost should go here, 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 here. Each part should have an individual cost, and the cost of your car is the sum of the costs. However, if you have ever bought a car, you probably have noticed that this is not true. In theory, there is a cost here, 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 but then in practice, the person who sells the car to you, well, makes a heavy discount, okay, or makes a special price for you, so in practice, the cost is here. Okay. However, if I were going to build this kind of database with the cost here, and maybe here an official cost, so if you are submitting this database to me, please, in this way, please, you must write a note here indicating that the field cost here in table cars is inserted because very often the cost of the car is not the sum of the official cost, but it's subject to a heavy discount. Okay? Because otherwise I would complain that this cost could be calculated from the 4 costs. Okay? Another alternative could be and this is, I think, a good alternative to write here a discount percentage. Okay. So the cost is calculated as the sum of the 4 costs, and then a discount percentage is applied, and this makes perfectly sense. Okay. So the cost is calculated automatically by the database whenever you need it. So it's not stored inside the database as a datum, but it's calculated automatically by the database whenever you need as the sum of the 4 official costs. And then the discount percentage is applied because this is typical of car selling. However, I would say that very often the seller doesn't say, oh, you have a discount of 20%, but simply tells you, you have a final price of, so even though this is one of the most logic solution, it's still writing here directly the final cost remain the typical selling strategy. Okay, so this was just to show you that junction table can have several different foreign keys going out, okay, and it could be also the main table of the entire database in practice. Okay, and now I want to talk about the issue of let's write in red, orphans, okay, and referential integrity. And you may say that you may ask me, what do the two things have to do? Well, they are strictly bound. What is an orphan in a database? Imagine that there is a type of engine that your factory doesn't produce anymore. So that engine was continuously broken, so we decided to finally stop its production and change completely. Okay. So what to do with that engine, which appears here in the list of engine types? Well, to avoid that people in the future uh, order cars with that engine, you remove the record from engine types. Okay. So there is an engine type, let's say engine type number 7 with size 1700 cubic centimeters, power 200 whatever. Oh, I misspelled fuel. This should be fuel, not full. Fuel type, gasoline, etc., etc., etc. That type of engine is not produced anymore. So you remove that record. So it doesn't appear in the database anymore, and people cannot order it anymore. However, if you remove a record from here, what happens to the cars which were booked last year, which still have a foreign key here with a reference to this engine type? Well, to make it clear, I will put only these two tables, the cars table and the engine tables, in Excel, so you understand it better. Engine ID, size, power, fuel type. Engine ID, size, power, fuel type. I will misspell forever fuel. Manufacturer, model name, official cost. Manufacturer, model name, official cost. Okay. Imagine this table full of records. I don't write all of them. Then we have a record 234, okay, with size 1700 cubic centimeter, power 170, I don't know what, fuel type gasoline, manufacturer Bo XYZ, model name fire engine, official cost, this engine, if you put it into your car, cost 12,000 euros. Okay, and I have here this is the engines, and I have here the cars table, which contains the ID, the engine, the external, internal, and the tires, the final cost, and the owner. Okay, so imagine here you have a lot of records. One of them is records with engine 234, so the fire engine, external I don't know what, internal I don't know what, tires so we don't care, final cost 45,000 euros, and the owner me. Okay, and oh, we can put also the date here, by the way, just to make we have the side for discount percentage. Okay, so final cost and also the buy or order date. Okay, so official cost and final cost. So I ordered this car 3 years ago for 2003 or 2004. Okay. Now in 2017, engine. Oops. Sorry, wrong table. Okay. Order date 3/4/2014. Now in 2017, the company decided to stop production of engine 234. Okay. So what do they do? Well, let's suppose they decide to remove completely. So here we have 233, 235. These are other engines. I don't write all the details. They decide to remove completely this record from the database. Remove. In this way. Delete. Poof. What happens? It happens that if for any reason the database must find out how my car was structured, maybe because I go to assistance and they ask, oh, can you please repair my car? My car ID is 23432, and I look and they say, oh, engine is 3234, let's see. Obviously, this procedure is done automatically by a database program. Database program looks that searches, finds my record, finds my engine type, which is 234, goes to engine table, and 234 doesn't exist. We have created an orphan. So an orphan is a record containing a foreign key which refers to a primary key which does not exist anymore. So an orphan is a record containing a foreign key which refers to a primary key that doesn't exist anymore. So if you remove if you remove records from tables which have the one side, if you remove records from table which have the one side of a relation, you are creating orphans. I'm using this program as a whiteboard. Okay. So you cannot remove records from tables which have the one side. Okay. Several database programs, such as Access, will stop you and forbid you from doing this. Okay. Other programs, such as MySQL, will not care and will let you go on. Okay, so it depends on the program. In any case, this is a tragedy because it means that if you ask something to your database, the database program may crash or may give unreasonable answers. For example, if you ask what is the fuel type for Paolo Coletti's car, the database cannot answer because cannot find my engine in the engine table. Okay, so creating orphans is a tragedy and should be avoided at all. Okay, we say that when you create an orphan, you're creating orphans. We say that you broke the referential integrity. So database have these features which called referential integrity, which means that records in tables containing the one side of a relation can never be removed. Okay. Some database programs enforce the referential integrity, so don't let you break the referential integrity. Others let you break the referential integrity. It's up to you. For example, Access stops you and says you cannot do this because you are breaking the referential integrity. Do you really want to do it? Then it asks you again. Okay. So even sometimes after asking you 2 times, it doesn't let you do it. So referential integrity is a feature of a database. It means that records in table containing one side of relations cannot be removed. So what to do if that engine is not produced anymore? Do you have to continue to sell it forever and ever? No, there is a thing you can do, which is having another field which is still produced, still let's call it a variable, which is yes, 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 no. So you continue to keep the database, the record in the database, okay, but the record is marked as non-available. And so the database program obviously will be built in such a way that if you try to take a non-available engine for a new car, it won't let you do. Okay, let's go on and we talk about the details table. Oh, I need a new sheet. Okay. Okay, let's take a typical example. I will write here the text so you understand it better. Make it much larger. We are running by well, let's say e-commerce website where Word is suggesting where we side products. We obviously need obviously a products table, okay, and a custom table. Obviously customers. We hope. Okay, so this is the situation. Well, it seems a standard many-to-many relation. So products on one side, customers on the other side, and a many-to-many a junction table in the middle. Let's do it. But no, I don't do it. You do it. So please draw a table on the left called products and try to find out all the possible fields for table products. A table on the right called customers and find out all the possible fields for a customer. And in the middle, a junction table. Okay. Try to also here to set the junction table, set the relation, and try to find out some fields in the junction table. Okay, stop the video and really do it. Have you stopped the video? Okay, resume the video and we do it together. Here the table products. But why can't I use the black and among 3000 color there is not a black which is black? Okay. Okay. Products. Well, barcode. I think that the barcode, which is the barcode is a picture, but the picture only represents the number which is written below. If you have ever seen a supermarket, you have immediately discovered it. So the barcode is a numeric code which identifies every product type. So these are products, but I will say product types. Okay, if you write products, it's okay. I understand that you mean product types, but I write types just to make it clear. Barcode, then the product will have a name. If you're selling online, the product must have a picture, otherwise nobody will buy it. We'll have a weight, which is useful to calculate how much the shipping costs. Price. Oh, let's stop the price now for the moment. We'll talk about the price later, because in this database, where you put the price changes the things radically. Barcode name, picture, weight, something else. Well, description. Let's stop here. Completely on the other side. No, let's put it here for the moment. We have customers. These are not customer types, are customers. So to have a text code, you can identify your customer using the text code or the email address. Both can be used as a primary key. Let's use the text code. Just the primary key. And by the way, the barcode is obviously the primary key. First name, last name, email, something else, address, because we need to ship them. The address contains everything, including the town, the count, etc., etc. Do we really need the birth date? Oh, no, we can stop here. Let's write birth date, birthplace, nationality for tax reasons, and things like, oh, easy. Premium. Is it a premium customer? Yes, no. Okay, and now the junction table in the middle. Ta, ta, ta. Well, who orders what? Or who buys what? ID, which is the primary key. Product, customer, and quantity. how many relations? Oops. Pencil, the infinity symbol. I have to start getting this symbol somewhere. Okay. Since the professor, when he will correct my database, can have, just to be sure, okay, that customers goes there. Okay. Please, I repeat, never build relations like this. Look. Oop. And I don't know where does it arrive. Or even worse, there are some people who build a relation like this. Look. Ah. I sometimes see relations like this. Okay, I understand that it's from this table to this one, but the fields. Undo. Okay. Okay. This is the situation. Let's see whether it's correct. Each customer can make several, let's say, this is a buying act, so the act of buying something can make several buying acts. Okay. Each buying act has only one customer. This is reasonable. For the moment, we don't deal with group of customers who buy together. Okay. Let's see here. Each product each product type can appear in several buying acts. Oh, it is fine. Each buying act can contain only one product type. And this is not fine. So I will write here each. I will call it buying act. A buying act is a record here. Well, for some type of products, it's okay. For example, if you buy on eBay a used object, usually there is only one, so you usually buy them one at a time. Or if you go buying a car, you don't buy three different type of cars at the same time. You buy them one at a time. Okay, so each buying act contain only one product type. This is fine. But for the majority of trading of online e-commerce, this is not something that you want. It's not, you don't want your customer to buy only one product type and then close the transaction. You will prefer that your customer buy several product types, so also they save on shipping expenses, by the way. But this database does not allow it. So you can see each record here can contain a different quantity. So you can buy 20 products, but of the same type, because you can store only one barcode here. Okay, so it means that whenever a customer wants to buy something from your website, the customer puts that item in the basket and then cannot put any more items in the basket, must close the transaction and then restart everything. Well, you will lose most of your customers, including me. Okay, so this is a serious limitation. So the reason of this limitation is because this relation is not really one-to-many, but it's many-to-many, because a buying act should contain several product types, not only one. So the relation here one-to-many is not one-to-many, it's many-to-many. So we need to add another table here in the middle. Okay, now in order to add another table in the middle, I need to move away this table here, for example. Oh, the advantage of using a computer instead of a real blackboard. I need to move this table here with the relation. Oh, okay. So I'm making space. I need to remove things here. Remove things here. I will keep in this table only the administrative information about the order. So for example, let me, for sure not the quantity. not the product, but who is the customer. Okay, so we don't see that horrible thing. Who is the customer? The order date. So we put here only the administrative information. Sorry. The disadvantage at using a computer instead of a standard blackboard, or okay, here we'll put us another junction table. Let me remove thing, which will contain the logistic information, so details on which products have been ordered, etc., etc. Let's do it. Maybe if we use the one side, okay. So, and we call it order details, while we call this one orders. So this table contains the orders, and this table contains the order details. It will for sure have an ID, which is the primary key. Then it will have product and order. And these two are related, product to the barcode and order to the ID. This is one, this is one, this is many, this is many. Okay, we have also here the quantity. Okay, let's see how does this table work. Okay, so each customer can place many orders. Okay, an order is just your basket, the basket that you have while you're buying online, or if you never buy online, the basket that you have while you're going to the supermarket, the trolley. Okay, the only information that relevant information we have here is the order date. Okay, and then each order can contain several details, and each detail contains only one product type. So an order can have several lines if you're buying online, or if you're buying in a physical world, your basket can contain several items. Okay. So an order can have several details, and each detail has one product type. On the other hand, a product appears in several details. Okay. Each detail appears only one order. Since I imagine that you have problems understanding how does this order detail work, I will, as usual, write it in Excel. Let's make a new workbook. Okay, this is orders. So orders simply contains the ID 1, 2, 3, 4. Okay, the order date and the customer. Okay, the order date 2nd March 2017, again 2nd March 2017, this is the 3rd of March 2017, this is the 3rd of March 2017. Customer, suppose it's always me, no, it's for the first one, it's me. And then it's somebody else. Okay, so this is the order, what the order table contains. So let's say only administrative information, which is the order date and who is the customer. Then we have here order details. We have here also the products. Suppose that my company is selling, for example, fruits. Let me see. Barcode, name, picture, weight. So barcode, name, picture, weight. So the barcode, the name is a pear. Picture, imagine the picture of a pear and how much a pear should weigh. 300 grams if it is rather heavy. Barcode, apple, the picture. Barcode, watermelon, the picture. The weight of a watermelon is, we have big watermelon, 12 kilograms. Too much maybe. Pineapple. And the weight of a pineapple, it's a kilogram and a half. Okay. So, imagine that in my order, I would like to buy 2 pineapples, 1 watermelon, and 20 apples. So what do I put here? We have here ID, we have here order, we have here product and quantity. So ID 1, my order is order number 1. The product is, I want to buy 2 pineapples, so 2 pineapples. Then I did 2, order still number 1 because it's still my order. I would like to buy a watermelon. Quantity 1. ID 3. Order 1 because it's still my order. I would like to buy 20 apples. 20. Okay. So this table works like this. If in an order you have three different type of items, you have 3 different records. Clearly, as you can imagine, this details table, it's very soon growing rapidly. So it will become a huge table. But who cares? It's the computer who will handle it, not you. If you are going to handle it manually, it will be crazy. So a system like this will be completely crazy. But if you let a computer handle it, it's fine. The computer will easily find all the things which belong to order number 1 and put them together. Okay. All this structure, it's equivalent to the standard receipt that you receive if you buy something online, or even if you buy something at a supermarket. The standard receipt works like this. You have a piece of paper. It's a small piece of paper if it is a supermarket ticket. Here it is written your customer data. So first name, last name, address. Okay. Then here it is written order number, order date. This is a standard receipt. And here it is written product. Usually there is quantity. And then price, but we will talk about price later. Okay, and you will see a pineapple, quantity 2, price whatever, watermelon, quantity 1, price whatever, apple, quantity 20. Okay, so this part here, it's the details table. You can see. Okay, obviously you don't see the names here, but this is more user-friendly. So the details table corresponds to the inside of the receipt in which you have the details of everything you have ordered, while the other part, which is this one, is the other table. So this one. Okay. Let me undo. Why this has become green? I don't know. Okay. So this thing here contains the administrative information, and this the what you have ordered. So splitting it in this way gives us the possibility to put several items into the order. Oh, this to teach you that first, there is no limit to complexity. There could be situations in which you need another details table here or here. Okay, but don't worry, we will not deal with them. Okay, but also to teach you this example, because this is a really standard thing in many trading buy and sell applications. And in particular also to teach you that a junction table, because this was originally a junction table, can have also one relations going out. So it's not forbidden that a junction table has one relation going out. Now it's not a junction table anymore because it has lost the second foreign keys. But don't be afraid, a junction table can have also one relation going out for some reasons. Okay, so please, this structure, watch it again. Be very sure about the structure because it's the standard structure, and it's also the structure that I will use in the rest of the course, the practical part of the course, because it's a typical structure used in buy and sell applications. Okay, and now let's finally talk about the difficult issue, price. Where do we put price? Now I suggest you stop the video, try to put price into 4 different tables and try to think at the implications. So what happens if you put price in that table, and which will be the most logic solution and which will be the most illogic solution. Okay, really do it. Okay, assuming that you have done it, now let's talk about price. Let's start with the most logic solution, which is put price here. Okay. If you put price here, you are adopting a fixed price policy. It means that each product type has its own price. It's valid for every customer, for every time in particular. Remember that if you change your price, it's valid for every customer, for every time, for every order. Doesn't matter if the customer is a small one, a big one, the price is that one, fixed. So this is a fixed price policy. However, many people prefer to insert a price here. This is instead a fully flexible price policy. It means basically that you insert a price here. So the price changes for each order, for each customer, and obviously for each product, I assume. Okay. So price here, it's a fully flexible choice. It gives you the possibility to decide the price depending on the product, obviously, but also on the quantity. So if somebody buys a huge quantity, you can reduce the price a little bit. On the order, which itself means on the date and on the customer. So it's fully flexible. In fact, several databases like this have here an sort of official price, and then here the practical price. Okay. This is strongly illogic, but it's what people really do in practice. Let's see, is there any reason to put a price here? Yes, also putting the price here makes sense. It means that your price does not depend on the products anymore and not on the quantity. It depends on the date and on who is the customer. Okay. So, for example, you can adopt a policy of that a customer pays every time he plays. Obviously, this does not apply for vegetables, because if the price depends only on the customer, I will buy 300,000 things. Okay. But for example, if you go to a cinema watching a movie, well, the price depends only on the customer. Each customer pays a price. It cannot buy 20 different type of tickets. No, the customer buys a tickets only for himself. The price depends only on who is he. Well, there can be other strange situation. Another reason for putting the price here is that you're making a fixed price which depends only on the order. So you look at the order, you say, for this order, let's make this price. This is true, for example, for car selling. We've seen it before, because the seller makes a special price which seems to be a special price only for you. Okay. a final example, which is the most illogical, is to put the price here. Well, it seems the most illogical, but there are examples in which it can work. So the price depends only on the customer. Doesn't matter doesn't matter what the customer orders, okay, and when the customer orders something. Depends only on who is him. Well, this can apply, for example, for associations in which they have a yearly fee, which depends only on who is the customer, whether the customer is an important person or not, a rich, a poor person, etc., a young, adult, old, etc. And so the fee is standard. The customer can use the association services whenever he wants. Also, a gym, for example, can adopt this kind of policy. The price depends only on who is the customer. It doesn't matter on what the customer actually does in the gym. Can go and return whenever she wants. Okay, so putting the price here changes the situation. So wherever you put the price, the situation changes. I will write here what I like. I like something like official price. Okay, and here discount. Okay, in this way you can set an official price for the products and apply a discount which depends on everything. Or you could also write a discount here, so apply a discount which depends on who is the customer, or a discount here, a discount on any specific order. But the discount here lets you be totally flexible, so you can apply a discount on every item of each order, okay, and that's it. Even so, it's many companies usually do something like this. So apply a discount, a global discount on the order. So as it is just to show you that pay attention where do you put the fields, because the meaning changes. Some fields must go in some tables. So first name must go here. You cannot put the first name in order details. So the customer doesn't change first name every time you change the order details. Okay, but things as price and discount can go in different tables and can take different meanings. I expect that you use the most logical choice in the database. I tolerate choices use standard, use often, but please write here, write I put discount in table orders because typically a discount is made on the total order and not on individual details. Okay, so if you write something like this, okay, you just write a little note telling me what have you done, why have you taken this choice. Okay, let's go on to a strange issue, no, another strange issue, a strange issue. The situation is like this now. We build a database for contacts and numbers. We have already built this database. It was our second database, which handles okay. So a database for contacts and phone numbers. So we have already built it, which handles people as well as companies. So not only people, also companies. Let's see. Again, I don't have the black. Okay. So we have here the phones with number, which is a primary key, and owner. That's it. I built the table a little too big. We have here on the other side the originally we had the people table. Now we put people and company together. Okay. First name and last name. And we start immediately with a problem because companies don't have a last name or they don't have a first name depending on. Okay, so mixing a companies with people inside a telephone directory It's a problem because they're using different fields. But if you take a look at your smartphone or at your old style telephone, this is exactly what you do. I'm sure you probably have the telephone of some shops or or telephone of the university here. And you are in fact mixing the information of companies and telephones and people together. Okay. So how can we solve this issue? Well, there are three ways to solve this issue. The first one, it's the most used one, and I'm sure it's the one you use on your smartphone or on your old style telephone. But it's the less elegant one. However, it's the standard one which we use in practice. And it's this one. You build the fields which apply to the telephone to a company as well as to a person. So first name, last name, then birth date, which applies only to a person. And then what do we have? Contact person, which applies only to a company. Well, the contact person of a person is the person himself, obviously. This applies only to a company and whatever. Okay, we can stop here. Okay. Whenever you put a person inside, you will fill only the first three fields and leave contact person empty. Whenever you put a company inside, you will fill only first name and contact person and leave last name and birthday empty. We need also ID. And this is a compromise. Leaving fields empty, as you can see, it's not particularly appreciated by me, but this is a compromise, and it's basically the best compromise. Okay, and now the relation is one on this side and many on this side. I put it because otherwise at exam somebody will tell you didn't put. Okay. Okay, so this is the first solution for this issue, which is the not elegant but works. Okay. Another solution which is very elegant but doesn't work is the following. Let me clear it up a little bit. Ta, ta, ta. Too much, too large. Building a table only for people. And then building another table for companies. Maybe if we build a table in black. Okay. ID, name, contact person. The relation. Very elegant. Okay. You don't have empty fields here. People are put here, companies are put here. You always know whether something is a person or is a company. However, it doesn't work. Why it doesn't work? Well, because whenever you're searching for somebody, let's search for Paolo Coletti and you find the telephone number. This is pretty easy. Or you search for university and you find the telephone number. This works. But the vice versa doesn't work. If your telephone is ringing, the telephone number is ringing, the computer doesn't know whether to look for the owner in table people or in table companies. Because when the computer is here, it doesn't know whether to go in this direction, this direction. And most of the database programs will not let you do something like this. So this is elegant, but doesn't work at all. Okay. The third solution, okay, which works, but it's not very efficient, it's the following. Let's ta, ta, ta. The solution is the following. You build two separate databases. One for people and another one for companies. Maybe if we build one, okay. So two separate databases, one for people, another one for companies. This solution works fine, but honestly it's totally inefficient. Okay. Every time your telephone rings, your computer will have to search here and here. Okay. Hoping to find not to find the same telephone number. So it's non-efficient splitting, having two databases. Okay. So the first solution, the non-elegant one, it's at the end the most efficient and the only one used. But what to remember here is that a foreign key cannot have several relations going out. So a foreign key, like the ones we have done before, with two relations going out, it's forbidden. On the other hand, it's allowed for some reasons to have a primary key with several relations entering in. Okay, so a primary key on the one side can have several relations entering in, it works fine, not a problem. But a foreign key having several relations going out cannot be. Okay, so I will write here in red, so a foreign key may not have more. May have. Okay. For example, if you have here another table containing email addresses, you may have, I will build it so you understand better. Let's first of all change thing. This one. Then change color. Always was. So this is an example of how one side can have more than one side going out. This is allowed. While the foreign key with more than one relation going out is not allowed. This is allowed because it works fine. When you are here, you're looking for Paolo Coletti. Well, if you want to get his phone number, you go here. If you want to get his email address, you go here. So the database program knows perfectly where to go depending on what you ask. Okay. In the other example, well, you in both cases you wanted to get the owner of the telephone, and so you don't know where to go. But here you know perfectly where to go depending on what you want to know, whether you want to know the email address or the telephone. Okay, we have already talked about temporal and static databases. Let's go on to two structures which are very difficult to build with relational databases. So I suggest you not to do them. The first one is the hierarchical structure. A structure like the one you see, the president, the director, below are the boss, and then the employees. So it's a pyramid structure, a hierarchy. Well, it's difficult to build it because many of you are tempted here to build a table for the presidents, even though this table has only one person inside, a table for the directors, a table for the bosses, and a table for the employees, and a table for the slaves. Well, it's not the right way to do it because these people are all people. Okay? And so they can go into the same table. So building a table for each level and moving the persons from the people from one table to another one when they are promoted, it's totally silly. Okay? Especially the president's table with only one president inside. Okay? It's much better if you want to build a database for a hierarchical structure to have a table containing people, okay, all the people detail, with one field with an role, okay, or even better, why decided that, let's see, I will completely remove it, reopen it, wait 3 hours, no, new, it's already new. Oh, so now I have the black and everything I could dream of. So let's see how to model the hierarchy structure, even though I suggest you not to do it. So not a table for president, a table for director, a table for bosses. This will never work. A table containing people, because after all they are all people. They have a first name, a last name, a birth. They have the same features, a birth. Even though many people don't believe that the president has the same feature of the last of the employees, but a birth, place, and a tax code, which is also the primary key. Okay, and now here you can put role, in which you will write president, director, whatever. Okay, and if you want to have the knowledge of who is your boss, because here you have some people below director 1, some people below director 2, and some people below director 3. Okay, so if you want to get to know who is your boss, you write here, who is my boss, who is boss, okay, with a relation, this is a foreign key, going back here. This is one of the cases in which a table can have a self-directing, it's not forbidden. Okay, so for example, president is tax code CLT PLA. Okay, if you are a director, so your boss is the president, you will write in who is your boss the tax code of the president. So here you will have in who is your boss, you will have the tax code of the person who is directly above you. And the database is over. Database with one table and one relation inside the same table. Well, if you want to standardize the roles, because if you leave a role like this, everybody's free to write whatever. If you want to standardize them, you build a separate table with roles, name, which is a primary key, description, salary. If you build something like this, now the people are not free to write whatever they want in field role. They must write a name which is contained in table roles. Okay, so if you want to standardize the role here. But otherwise, the core of the database is this relation pointing to the same table, which mimics this the fact that director 1 is below president, that boss number 20 is below director 2, the fact that employee number 3000 is below boss number 21st, etc., etc. Another typical thing that you have a hard time mimicking it with a relational database is this thing here. So a standard production chain where products go through a first stage of production, a second stage, a third stage. For example, products are designed, assembled, and shipped. So 3 stages of production: design, assembled, and shipped. Okay. Well, I know that also here many of you are tempted to build a table for first stage, a table for second stage, a table for third stage. All the 3 tables will contain products, and you will move the records from one table to another one. This is silly, moving records from one table to another one to mimic the process. No. Also here, the solution is to build a single table containing information on the products. And they will have a stage which indicates in which stage they are. So the stage will be 1, 2, 3, depending on which stage they are. Or you can have exactly as here, a stages table which contains the stage ID, the name, or the stage name, which is the primary key, description, and stuff. One, many. Okay, in this way you have, if you want to have also the other information that this stage comes before this one and before this one and so on, you can put here, if you want, the field next stage, which is a foreign key which points at the next stage. Oops, severe mistake here. Let me finish this and then I will correct the severe mistake. So let me finish this. So in this way, you will have here the indication which is the next stage. Okay, which is obviously the name of a valid stage. Here I made a severe mistake. I will correct in red. This is a mistake which cost a lot of points in a database correction. This is the one side, obviously, and this is the many side. It's a primary key, can never be a many side. Okay. Okay, so these two structures are not mimicked building a table for each level or a table for each stage, but only one table and having the reference at which stage or at which level you are. We have already talked about orphans referential integrity. Just a final instruction on how to design a database. Well, some of you who are watching this video will have to design a database at home as a group work. Others will have to design a database at exam, depending on which kind of course are you taking and whether you're doing a group work or not. However, the suggestions are, well, some suggestions are valid only for the people who are doing the exams. Other suggestions are valid for both. Well, if you're doing the exam, so you receive a description from me, please read it. Don't skip it. Read it 3 times. I'm really serious, really 3 times. You must have a very, very, very clear idea of the practical situation. Okay? So you must have an idea of how the situation works. This applies also to people who are designing a database alone. So as a group work at home, have a clear idea of what is going on. Don't build tables just because you want to draw some tables. You must have a clear idea of what your database should represent and how the information should contain, etc., etc., etc. A clear idea. Otherwise, you are building for sure a database with a lot of basic mistakes. Okay? Then you should start with external tables. The external tables are the ones which don't have foreign keys, basically. So the customers, the products, the ones which contains physical objects or obvious things. These are identified by things which rarely change, such as places, people, object. They are always usually evident from the description if you receive a description from me. Well, you can see that in all the databases that I've designed here, I always started from the external table, customers, products. I never started from a junction table. It's a suicide. Okay, even though I have enough experience to start also from a junction table, but I still start from the external tables. Okay, so start from those ones. Decide which relation to have among themselves, and then check that the relations are logical according to a real situation and are compliant with the description if I give you the description. Okay, and build them. Okay, pay attention that you may have to insert junction tables if the relation is many to many. So after having built them, check that the one-to-many and many-to-one are properly oriented, and not as I did 5 minutes ago with the one and many written wrong. So do also always the, for each record here we have many things here, for each record here we have one thing there. Check that no relation is one-to-one. In particular, check that your one-to-many are not in practice one-to-one. And if you have a many-to-many, you should insert a junction table. And eventually also a details table, so 2 junction tables in the middle. At the end, I would really check again that the one side is really a one side. Okay, if you have received a description from me, check again that the database is compliant with my request. Okay, you will have a description with several requests. Check that the database is compliant. And check that the database is able to satisfy my final question. I always write at the end of my description, your database must be able to answer the question, when did Mr. Smith buy his house? Clearly, if you don't have the name of the surname of the people, you cannot answer this question. And if you don't have a date, a by date, you cannot answer this question. So check that your database can answer this question. Then put all the other fields. You will have also to put the field types and the options. We will talk about this later on. But then put all the other fields with the appropriate field types. If you are inserting non-obvious fields such as number, many of you write number, but a number of what? So please, a description of this non-obvious field. In particular, if they are written in languages which are not English. I tolerate them, but a description. Thank you. Okay. You will have to build queries. Okay. In the queries, avoid using fields that you don't have. So don't build a query such as when did Mr. Smith buy his car, and your database doesn't have a by date, because I will mark your query as wrong, not able to be responded. Okay. If you take non-standard choices, for example, you do a one-to-one relation. In some other cases, a one-to-one relation can be tolerated. Please write a strong justification, very strong justification, very, very strong justification, okay? Because I tend to be very suspicious of non-standard choices. Okay, and the theoretical course is over. Goodbye to the practical course.